Alright guys, welcome back to Underground Science, and in this video we're going to be looking at the non-oxidative phase of the pentose phosphate pathway. Alright, and so this is the part 2 because we looked at the oxidative phase in the oxidative phase of the pentose phosphate pathway video. Alright, so here's a screenshot of what we went over in last video, right? Some parts of it got cut off though, like glucose 6-phosphate, right, gets converted into 6-phosphogluconolactone via glucose 6-phosphate dehydrogenase, and we said we make an NADPH molecule here. Then we said we have 6-phosphogluconolactone converted into 6-phosphogluconate via gluconolactonase, and we said we use a water molecule yielding a hydrogen cation. Then we went from 6-phosphogluconate to ribulose 5-phosphate, and we actually made NADPH via our 6-phosphogluconate dehydrogenase enzyme. And because we went from a 6-carbon molecule to a 5-carbon molecule, we had to lose a carbon, and we lost that carbon through the release of carbon dioxide. And we said that all of this, right, from glucose 6-phosphate to ribulose 5-phosphate, was the oxidative phase of the pentose phosphate pathway. Now let's look at the non-oxidative phase of the pentose phosphate pathway. Alright, so from ribulose 5-phosphate, let's actually write the compounds down first. So from ribulose 5-phosphate, we actually go and get converted into ribose 5-phosphate. So ribose 5-phosphate and xylulose 5-phosphate. Xylulose 5-phosphate. So 5-carbon molecules. Okay, so ribose 5-phosphate and xylulose 5-phosphate. Now, when you go from ribulose 5-phosphate to xylulose 5-phosphate, we actually use an epimerase enzyme. All right, so from ribulose 5-phosphate to xylulose 5-phosphate, we use the enzyme called ribulose 5-phosphate epimerase. All right, so let me go and write that down. So ribulose 5-phosphate epimerase, 5-phosphate epimerase. All right, so that's the enzyme you use here to go from ribulose 5-phosphate to xylulose 5-phosphate. However, to go from ribulose 5-phosphate to ribose 5-phosphate, we use a different enzyme. We use an isomerase enzyme. All right, and remember, if we have an isomer of a compound, that means that we have a different structure but same amount of atoms. All right. So anyway, from ribulose 5-phosphate to ribose 5-phosphate, we use an isomerase enzyme, and that enzyme is called ribulose 5-phosphate isomerase. Okay, so ribulose 5-phosphate isomerase. All right. Now from here, after we make ribose 5-phosphate and xylulose 5-phosphate, we actually use a transketolase enzyme. So let's go and write that down. Or first, let's go and draw our arrows, right, of what ribose 5-phosphate will convert into and what xylulose 5-phosphate will convert into. Or you know what, let's just go and write the compound will convert into first, all right? And then we'll write the enzyme down, which we just said it's a transketolase enzyme. But anyway, ribose 5-phosphate will actually convert into, hopefully this compound's familiar to you guys from glycolysis, right? But ribose 5-phosphate will convert into glyceraldehyde, right? Glyceraldehyde 3-phosphate. All right, so hopefully this compound's familiar to you, right? Remember, we made glyceraldehyde 3-phosphate when we split fructose 1,6-bisphosphate via the aldolase enzyme. All right, so glyceraldehyde 3-phosphate is made here because ribose 5-phosphate converts into glyceraldehyde 3-phosphate, and xylulose 5-phosphate actually converts to a compound called cetoheptulose. Now, I'm pretty sure I'm not pronouncing this right, but cetoheptulose 7-phosphate. Okay, so it's a 7-carbon structure. Cetoheptulose 7-phosphate. And again, for both of these reactions right here, so for this one and this one, all right, so the conversion from ribulose 5-phosphate to ribose 5-phosphate, we used an isomerase enzyme, right, and an epimerase enzyme for this reaction. But when we went from ribose 5-phosphate to glyceraldehyde 3-phosphate and xylulose 5-phosphate to cytoheptulose 7-phosphate, we used a trans-ketolase enzyme. All right, so a trans-ketolase enzyme stimulated both of these reactions. Now what can happen is that cytoheptulose 7-phosphate and glyceraldehyde 3-phosphate can actually combine, so they can combine with each other, right? So they'll combine, and so let me just go and draw like a sign like that saying they can combine, and then after they combine, what can happen is that glyceraldehyde 3-phosphate can then form, or can then turn into fructose 6-phosphate. All right, can then turn into fructose 6-phosphate. All right, and then cytoheptulose 7-phosphate can actually again combine with glyceraldehyde 3-phosphate and convert into, after it combines, it'll convert into erythrose 4-phosphate. Okay, and so right here we can actually stop for a little bit and see that glyceraldehyde 3-phosphate right here that was formed from ribose 5-phosphate via the trans-ketolase enzyme, right, can actually go to the glycolysis phase, right? So this can actually go to glycolysis, all right? And this fructose 6-phosphate can actually also go to glycolysis, right? Because we have fructose 6-phosphate in glycolysis. So this can also go into the glycolysis pathway, okay? And now what happens is that erythrose 4-phosphate will then get acted upon by an enzyme, a trans-ketolase enzyme, right? And I just realized that we didn't even write the enzyme here, right? So when glyceraldehyde 3-phosphate and cytoheptulose 7-phosphate combine and then leads to the formation of erythrose 4-phosphate from cytoheptulose 7-phosphate and leads to the formation of fructose 6-phosphate from glyceraldehyde 3-phosphate, this reaction right here, right? An enzyme called, or a transaldolase enzyme that's the enzyme that actually catalyzes both of these steps, all right? So again, cytoheptulose 7-phosphate and glyceraldehyde 3-phosphate can combine and lead to the formation of erythrose 4-phosphate from cytoheptulose 7-phosphate and fructose 6-phosphate from glyceraldehyde 3-phosphate via a transaldolase enzyme. Now, erythrose 4-phosphate can get converted into glyceraldehyde 3-phosphate, glyceraldehyde 3-phosphate, all right, and also a xylulose 5-phosphate in the vicinity, right? So a xylulose, so let's go and write this down in a different color. So if we bring, actually, you know what, let's go and squeeze in right here. So a xylulose 5-phosphate, sorry about this random dot, a xylulose 5-phosphate in the vicinity can also be converted into fructose 6-phosphate. All right, so what happened here is that erythrose 4-phosphate got converted to glyceraldehyde 3-phosphate and xylulose 5-phosphate again can get converted, right, in the vicinity can get converted into fructose 6-phosphate. Now the enzyme that drives both of these reactions, so there's an actual enzyme, right, that drives both of these reactions, all right, that enzyme is again a trans-ketolase enzyme, all right, so a trans-ketolase enzyme, all right, so this, right, drives both of these reactions. And again, we saw this enzyme get used here when ribose 5-phosphate converted into glyceraldehyde 3-phosphate and xylulose 5-phosphate got converted into cytoheptulose 7-phosphate. All right, and then from here, what can happen is that this fructose 6-phosphate can actually go to the glycolysis phase, right? So it can actually go to the glycolysis phase, and this glyceraldehyde 3-phosphate also can go to the glycolysis phase, all right? Remember, the pentose phosphate pathway is happening in the cytoplasm as well as glycolysis, okay? And so again, remember here in the non-oxidative phase, we actually made ribose 5-phosphate, which is another important goal of the pentose phosphate pathway. Why? Remember we said to synthesize the nucleotides in our DNA and RNA. All right. And so this is the basic idea of the pentose phosphate pathway. And so from here, so let's go and highlight this out. From here all the way to here, right? This was the non-oxidative phase of the pentose phosphate pathway, the non-oxidative phase of the pentose phosphate pathway. All right, guys, and so this is the basic idea of the pentose phosphate pathway. I really hope this video made sense to you guys. I hope to see you guys in my future videos. We'll talk about more cool topics about biochem, physics, and chem. Don't forget to hit that notification bell, like, and subscribe. See you guys later, and stay safe.